Teresa, and welcome back to my math YouTube channel. And today we're going to be going over notes 1.3 in the AP Pre-Calculus curriculum. And so let's get started. The title of our notes today is the rate of change in a linear and a quadratic function. So as you can see, the one on the left is a linear function and the one on the right is a quadratic function. We know this because based on your other classes, your previous classes, you should know that a line is basically also known as x, and a quadratic equation is always known as x raised to the second power. Alright, so as mentioned in the video before, what is the average rate of change? Well, the average rate of change is always the slope of the line or the slope of the function. And just because the function looks a bit different, like in last video we were mainly focusing on linear functions, and now we're gonna take a look at quadratic functions. It's the same process, it just looks a little bit different, but it's the same formula. And the formula is, again, change in y over change in x, or y2 minus y1 and x2 minus x1. You're probably wondering how we got these, what do these y2s, y1s mean, or these variables? Well, you literally just grab 2 points from the graph, and as you know, your point, if you grab a point on the right, it's a, let me actually show you. Let's say we grab this point, right? I don't know what point it is, but let's just name it x, y, right? And let's grab another point. This one could be x2, y2. And so now you could kind of like guesstimate, and not guesstimate, but like now you could just plug these these numerical values into the formula, which would give you the rate of change. Next. Alright, so basically another refresher. Okay, here's another refresher from last video. What is the average rate of change of this line? Well, we're given that the line is y equals 2 divided by 3x. And so we can easily calculate the rate of change by basically, again, getting these 2 points. Getting these points, or not those points, sorry. Getting these 2 points and basically putting them into the formula. Change in y over change in x. So this point is going to be 6, 4. That's our x, that's our y. This is going to be, that's our 3. 3, 2. And so now we just plug that in. So, change in x over change in y. So y2, you could put in a calculator, and I truly recommend buying a TI-84. Actually, most pre-calculus classes, it's a requirement to have a TI-84. And if you can't afford a TI-84, most school libraries offer it, offer like loans, or not loans, but they like, you borrow it and then at the end of the year you bring it back. And so yeah, that's a good resource. And sometimes your teachers have extras. I know these could be pretty expensive. They're like $100 for a calculator. And if you don't have one, you could always use the online version. There's an online free version, I believe. But just keep in mind, you are allowed to use the TI-84 during the AP test. So I highly recommend getting used to that calculator. So now that we've got our TI-84, we could put 4 or 2 minus 4 divided by divided by 3 minus 6. So our rate of change, who would have guessed, is 2/3. And you're probably wondering, what does this mean? Well, again, this is basically just a refresher, honestly. For your other classes, literally that's the m value. This is also known as y equals mx plus b, and what the slope is, see, m literally matches. So that's another way to verify it, because like I know some questions in tests are like identify where the student made an error, and then they give several steps, and you have to identify if it's whether step 1 where they made the error. And so this is where you can verify that the slope and the rate of change are equal. Next question. Find the rate of change of the average rate of change of a linear function. So, you're probably wondering, is that a typo? Well, actually it's not. Well, usually we use the rate of change to find many different things. And so, yeah. Let's find the average rate of change of the average rate of change. So you're probably wondering, how do we start this? Is there like a specific formula? Is there another formula besides the average rate of change? Well, actually, it's not hard. So, you see these, we're given a function. We're given a linear function. And we're also given this data table. Well, just like the previous videos, we get these x values and plug them into the equation for x, and then your output value, which is a y, you put them on this side. Now that we got this data table set up, let's find the average rate of change of each. You're probably wondering, how do we start? Well, it's just like the others. It's just like the other examples. We use the change in y over change in x, and so we kind of pair these guys up, and then after we find the rate of change of them, we pair these guys up, then find the rate of change of that, then we pair these guys up, find the rate of change of that, finally we pair these guys up and find the rate of change of that. Now that you found the average rate of change of all of these, I'm sorry for this red-orange box, or this red box, but it's writing it as an error, but it's mathematical notation, so there's no error. Anyways, now that you got the rate of change of these, we need to find the average rate of change of the average rate of change. So now we just do the rate of change again. And if you notice that I kind of skipped a step, or I didn't really skip a step, but I didn't write me doing the whole rate of change part again, since I believe in you guys. I believe you guys know how to do it. So just kind of skipped it to wrote down the answers, and that's what I'm gonna do once again. And you probably got 0, right? Well, you're actually correct. The rate of change of the average rate of change of a linear function is 0. And this works for every linear function, and this basically proves that it's a linear function. Thank you once again for watching my YouTube video on topics 1.3, rates of change in linear and quadratic functions. Hope you like and subscribe if you like my content, and don't forget to follow the TikTok, because I will be posting minute-long videos explaining, kind of like summarizing the most important details of these notes, basically. So like, let's say you have a quick quiz about unit 1, or units 1.1 to 1.3. You can watch those TikTok videos if you don't want to watch these 10-minute long videos, so you gotta cram real quick. Watch those 1-minute videos. Should be pretty helpful. If you did the amount of studying. It's literally just a refresher, so it's gonna go boom, 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 instead of like these videos where it's kind of spaced evenly apart. So yeah, as mentioned before, don't forget to like and subscribe. And yeah, thank you for watching.